Hello students. So we will continue our discussion on number system. Okay. So in today's lecture we will be seeing about rational numbers in decimal representation and their representation on real numbers, and if two integers are given and we have to find out given number of rational numbers, we will see their methods, properties of rational numbers, and the similar things we will be learning about for irrational numbers. So let's jump into our first topic. So the first subtopic is rational number in decimal representation. We already know the rational numbers are of the form p upon q, where q must be some non-zero integers and p and q both are integers. Okay, and there is another way of defining the rational numbers, which is if we are given a decimal form, then if the decimal form is terminating decimal form, then it is a rational number. If, for example, like if in fraction 1 upon 2 is equals to 0.5, so it is a terminating decimal number. So terminating decimal number. What I mean by terminating decimal number, it means the finite number of digits occur after decimal. So if we see the decimal is here and the right to the decimal there is only one digit, so the finite number of digit. Okay, similarly here, so 1 2 3 4, only 4 digits are given, so it is terminating. Similarly, 2 digits are giving to the right side of the decimal, so it is terminating. So this decimal form or these all decimal forms are rational numbers. Sometimes it happens that the after decimals the digits do not terminate, but they repeat itself. For example, 0.333 and so on. So the 3 is repeating forever, repeating forever. Okay, so these types of form, we can easily see that it is non-terminating because it is not there is no finite number of digits which we can stop. Okay, which we can stop. So it is not terminating, but they are repeating. So 3 3 3 3 3, everywhere is 3. So these forms, these types of forms are also rational numbers. Okay, so this way we have different way of defining rational numbers in terms of terminating decimals or non-terminating and repeating. Okay, now we are given some examples 2 by 3 from the fraction or the p upon q form. We can easily say that it is a decimal, it is a rational number. Similarly, it is a rational number if we see their decimal form, they are non-terminating but they are repeating. So if any digit is repeating, then we write the little bar over here over the number which are repeating. For example, here 4 5 4 5 4 5 is again and again repeating, so we write 0.45 bars. So bar here represent the repeating pattern of 4 5. Okay, now let's see. Now representation of rational number on a real number line. So how we going to represent our rational numbers on a real number line? We already seen we have a real line like this. Okay, so we have a real line like this where at the center we have 0, right to the 0, we have positive numbers, integers, whole numbers, etc., rational numbers, 1, 2, and to the left of 0 we have negative numbers, negative real numbers. Okay. So if one say how I am going to represent my this rational number, this half. So if you try to make the decimal form, we know it is 0.5. Okay. So we know the 1 by 2 must be somewhere here in between 0 and 1. So if I zoom this picture, let's zoom it. So 0 is here, 1 is here, here line goes to 2, here extending to -1. Okay. So this fraction says divide this 0 to 1 region into two equal parts. So how we are going to divide it? Just putting one little small mark here. So it divides two equal parts. Now we are given that we are considering only one part. So the one part is this. So we reach to this point. So this is our 1 by 2, the representation of half. So now similarly 3 by 7 we can represent here like this. So we are given our real number line. Okay. And 3 by 7 we are given 3 by 7. So we simply take our numbers, simply take the center which is at 0. Okay. And to 1 we divide the 0 to 1 part into 7 equal parts, and then taking 3 equal parts out of 7, we, let's say 1, 2, 3, 4, 5, 6 and the 7. We divided the whole part into 7 equal sub parts. Okay, so the 7 equal sub parts are 1, 2, 3, 4, 5, 6 and 7. Now how many of them out of 7 we want? Only 3. Okay, so we want this one and this one. So after this, so the 3 by 7 will be this one. Okay, so 3 by 7 will be this one. So 3 by 7. Here this in this manner we can represent our fractional rational numbers onto the real number line. Okay, move on to the next. Here we are given 13 by 7. So it is a improper fraction. Improper fraction. Okay. First we try to write it down in a mixed form. So the mixed form will be 1 whole 6 by 7. 1 whole 6 by 7. So this means 1 plus 6 by 7. So what we are going to do? Just simply make a real line. So here is our real line. Here is our center 0. We first move to 1. So here is 1. Okay. Now after this we are going to represent 6 by 7 with using previous steps. So in this way we know the 13 by 7 is in now 1 to 2 region. From 1, the 13 upon 7 must be in the region from 1 to 2. Okay, because we easily see from the mixed fractions that the 13 by 7 can be rewritten as 1 plus this fraction form, this number. Okay, so now So similarly, we how into 7 equal parts we divide our region of 1 to 2. So we divided 1, 2, 3, 4, 5, 6, 7 into 7 regions, equal regions. Now, out of 7, how many we want? We want 6. So we want this one, this one, this one, this one, this one, and this one. So after getting these one, we reach to here, and uh, this is our answer. So the 13 by 7 will be positioned at here. Okay. Now let's move on to next. This is the similar question to the previous. Okay. So it is the homework for you to how we get to here. Okay. Homework for you. Okay. Now, now if the in previous question the rational number is given in P upon Q form. Okay. Either in proper fraction, either in proper fraction, or in improper fraction. Improper fraction. Okay. So what if we are given a rational number in decimal form? Okay. So decimal form with terminating digits. Okay. So let's find out. So 2.5. 2.5, what it means? So we just nothing we have to do, just plot, just make a real line. So here's our real line. The 0 is marked here. The 0 is marked here. Okay. Now we take regions 0, 1, 2, 3 and so on. We have to just take 3 maximum because we are given with 2.5 number, and divide every region, this region, this region, and this region into 10 equal parts. We have to divide into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay. So the 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Now what we will do? What we will do will similarly we do for this region 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Similarly. So here one is missing, one part is missing. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Similarly here. Again we do for this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one is extra. Okay. Now we know we have to get to the point 2 first. So where is 2? 2 is here. So we are standing here. Okay, standing here. Now we have to move only 0.5 part, which is the fifth part of the 10 equal subparts. So the fifth part is this one. So 2.5 will be here. So it is marked as there. Okay. Let's move to next. Similarly, 2.65. How we going to represent it? In a similar manner, we first get to the 2, and then from the region 2 to 3, we divide the region into 10 equal subparts, and then going to the 10 sub-equal parts, for example, the division is given here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and first we are here at 2. Now we get to the 2.6 part, which is here, after getting 6 part, which is here. So now we are at 2.6. We have to reach to the 2.65. So again we have to divide our region. So now here our region is 2.6 to 2.7. So our region is 2.6 to 2.7. So now here we also divide it into 10 equal parts: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, to which point we have to stop? We have to stop at when we get the our number 5th part. So 5th part is here. So we stopped here, and this is our position now. So this is a representation of 2.65 on real line. Okay, I hope the process is clear. Moving on to next, I hope this is your homework problem. Okay, so visualize the representation of 5.37 bar on the number line up to 5 decimal place. That is, we have to represent 5.37777 up to 5 decimal place. Up to 5 decimal place means we are going to plot the point on number line 5.37 bar up to 5 decimal places. That is, we stop after getting 5 digits after decimal. So 1, 2, 3, 4, 5. So we have to plot only this number 5.37777. Okay, you just no need to be it is very easy. Similarly to the previous problems, we have to magnify every time we get to our position. Oh, okay. So let me do it for you. So first of all, draw a number line. The starting point is 0. So first we have to get to the 5th point. So we know after 0, 1, we get 2, we get 3, we get 4, we get 5, then we get 6. Now we are at here. Okay, now we have to plot this. We are here. Now the region which we have to magnify is 5 to 6, this region. So we magnify this region. Now the starting point is 5, ending point is 6. Okay, now again we have to divide it into 10 equal subparts: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now we want 3. We stop until we get the 3rd part. So this 1 part, 2 part, and the 3rd part. So here we reach to the point 5.3. Now magnify again. What we have to magnify our part to 5.3 to 5.4. So the magnification is like this. Okay, so the 5.3 is the starting point and the ending point is 5.4. So again we have to divide it into 10 equal parts: 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. So now we stop until we get the 7th part. So we are at now 5.3. Now the 7th part is at here. So 1, 2, 3, 4, 5, 6, 7. So the 7th part is here. Now we are at 5.37. So repeating again and again until we get to this 7. So in this way of magnification, we will represent our number up to 5 decimal place. Okay, clear? I hope you can carry out the remaining process. So let's move on to next. So as the solution is also given, but I recommend that you must try by yourself. Okay. Now if a rational number we have to find out, but in between what numbers? If suppose that we are given that 2 and 3 numbers, the number 2 and the number 3, and one says that find out 4 rational numbers. We have to find out 4 rational numbers. So how we gonna do that? So let's see. It is quite easy. So how we are going to just easy? So we know 2 is equals to 2 by 1 and 3 is equals to 3 by 1. We try to make our fractions like fractions. Like fractions means having both denominators equal to each other. Here both are equal. Yes. So we try to increase the denominator number. So let's multiply and divide our fraction by 12. Okay. So the 24 by 12 is equals to 36 by 12. So by this process we can easily say that 25 by 12, 26 by 12, 27 by 12 and 27 by 12, 28 by 12 and the last was 36 by 12, which is, we know the 2 and is equals to the 3. So we find out 4 rationals of the form P upon Q between 2 and 3. Okay, clear? You find it quite simple task to find out rational numbers between any two integer numbers. The process is simple. If A and B is given, just make the denominator of both equal and large enough so that you can find out the given number of rational numbers easily. Okay, let's move. So here find the 3 rational numbers between A and B. So one method is to, by the previous method I gave, or there is another way that let's try out the another method. So if A is here and B is here, we know A is less than B, so A is at the left side of B. We know A is less than B. Now add A to both sides. Now add A to both sides. Okay, so 2A is less than A plus B, imply A is less than A plus B by 2. Okay, Similarly, adding b to both sides, we get a plus b less than b plus b, which is equals to 2b, and further equals to a plus b by 2 less than b. Clear? So from here we can see that a plus b by 2 is greater than a, and a plus b by 2 is less than b. So we know a and b, in between a and b there is a plus b by 2. Okay, if a is any number, b is any number, adding both numbers and dividing by 2, this number will always be less than b and always strictly less than a. So this number always lie in between a and number b. Clear? For example, let's see an example. If a given to 3 and b given to 4, then adding both number 3 plus 4 and dividing by 2, a plus b by 2, which is 7 by 2, we know 7 by 2 is equal to 3.5, okay, which is greater than 3 and less than 5, okay, less than 4. So less than 4. See how we find out the rational number between two given rational number. So in this way we can also find out more numbers. How? Now let's see, our a is 3 and b is 3.5. okay, so I can find out the number a plus b by 2, which is 3 plus 3.5 by 2, which is 6.5 by 2, and this number must be less than 3.5 but greater than 3. So by applying same method again and again and again, on a and b, we get a plus b by 2 here, somewhere here, and if we apply onto these numbers, we get here a plus b by 2 here. Again, if we apply on these numbers, we again get some number here. So we can find out as many as numbers one asked by using just a plus b by 2 formula. Okay, clear? Now let's move. So this is the quite simple method to use. So we already seen these steps. Let's carry on. So we know a plus b by 2 lies between a and b. The first rational number between a and b is a plus b by 2. Now we have to find the 3. So how we are going to find out the remaining 2 rational numbers? Just do nothing. We know a, we know b, we get to one rational number in between a and b is a plus b by 2. Now for finding the third rational numbers, just do nothing. Take a this and b this. Now a is a, b is a plus b by 2, and we know a plus b by 2 is less than b and greater than a. So doing this, we get some number here. Okay, we get some number here. So this is our process. So a plus b by 2, 2. So this is a is a, b is a plus b by 2 by 2. Okay, now solving, we get just 3a plus b by 4, and we already know this 3ab plus by 4 is greater than a but less than this number, and this number is less than this. So in this way we have two rational numbers between a and b. In similar method, taking this as b and taking this as a, okay, taking this equal to b and this equal to a, and applying the a plus b by 2 formula, we get this. Okay. Moving to next. So try this problem. This problem is similar as previous problems. So I hope you can easily find out the three rational numbers. Okay. Let's move. Okay. So these are the just similar problems. Okay. Now let's see the properties of rational numbers. So what are the properties of rational numbers? Assume we have three rational numbers a, b, c. Okay, three rational numbers a, b, c. So first property says that if we add two rational numbers, first we add the first number and then the second number, the answer will be equal to the if we add second number and then first number. Clear? Let me take an example. So we have 2 by 3 and 4 by 1, and we add 2 by 3 and 4 by 1, we get 3, 2 plus 12, which is 14, which is 14 by 3. Okay, now if we add 4 by 1 plus 2 by 3, we still going to get the same answer. So this property a plus b, okay, so say a and b, so this property a plus b equal to b plus a is called commutative property. Okay, clear? Now adding any in any order doesn't change our answer. Now seeing the second property, the associative property says that if we have three rational numbers, if we add a and b first and then add c, the answer will be the same if we try to add b and c first and then a. So let's see example so you can understand better. So taking a and b as similar to 2 by 3 and 4 by 1 respectively, and taking c to equal let's say 1 by 1. So the a plus b, if we try to add a plus b first, we get 14 by 3, and then a plus b, then add c, we get 14 3 plus 1 by 1, which is 3. 14 plus 3 is 17 by 3. Okay, and now if someone add like this, first he adds b and c, together, that is 4 by 1 and 1 by 1, he gets 5 by 1. And after adding B and C, then add A, B plus C. What he will get? He will be getting the same answer. He will be getting the same answer. So 2 by 3 plus 5 by 1 is equals to, let's verify that. So 2, so it is 2 plus 15, which is 17 by 3. Yes, both are the same. So this property in rational numbers also holds. The adding any two number first and then the remaining number is the same as the adding the B and C to the first number. Okay. Now additive inverse. Additive inverse says if we have a number A and adding minus of A, we will get 0 always. So what do we mean by that? We mean that if a rational number is given, for example 5 is given, then adding minus of 5, we will get what we will get. Let's solve. We will get 0. Okay, so adding A to minus A, we always get. So solving this plus and minus, we get minus. So A minus A is 0. So we always get 0. So this is our additive inverse, and minus A called as additive inverse of A. Okay. Now let's move to the multiplicative properties of commutativity. Okay, if two rational numbers A multiply with another rational number B gives the same answer as multiplying the number B to A. Okay, for example, the 3 upon 2 okay, 3 upon 2 is 3 upon 2 is equals to A and B is equals to 4 upon 1. So multiplying A into B, which is equals to 3 upon 2 into 4 upon 1, we will get 3 into 4, 2 into 1, which is 12 upon 2. Okay, now if we multiply B into A, which is equals to 4 upon 1, multiply by 3 upon 2, which is 4 into 3 upon 1 into 2, which is 12 upon 2. So both the answers are same. Okay, clear? So this property also holds. In the similar manner, associative and multiplicative properties also hold. Associative is easy. A multiply B multiply C. First we multiply A and B and then multiply with C is same as multiplying B and C together and then multiply with A. Okay, now multiplicative inverse, this property says that if A is any rational number multiply with 1 upon A, we always get our answer 1. Okay, clear? So for example, let me take a quick example. Say A is equals to 3, then 1 by A is equals to 1 upon 3. And A into 1 by A, which is equals to 3 into 1 by 3, which is equals to 3 into 1 upon 1 into 3, which is equals to 3 by 3, which is equals to 1. So 1. Let's move. Now, so the distributive property. So it says the distribution about multiplication on addition. So it says if we add B and C and then multiply with A is same as multiplying A with B and multiplying A with C and then adding both the products, the answer will be same. So take an example that 1 by 3, B is 1 by 2, C is 1 by 4. Now B plus C is equals to 1 by 2 plus 1 by 4, which is equals to 3 by 4. Clear? And now A multiply with B plus C, which is 1 by 3, 3 by 4, which is equals to 1 into 3, 3 times 4, which is 1 upon 4. Okay. Now A into B, what is equals to? A into B is 1 by 3 times 1 by 2, which is equals to 1 by 6. And A into C is equals to 1 by 3 into 1 by 4, which is equals to 1 upon 12. Now adding AB plus AC, we will get 1 by 6 plus 1 by 12, which is equals to 2 plus 1 by 12, which is further equals to 3 by 12. And here we can cancel out the common terms, which is 3. So we are left with 1 upon 4. So we verified this property also. Let's move to another. Now we talked about properties on rational numbers. Let's talk about on irrational numbers. What was the definition, or we discussed the definition for the irrationals is quite simple. Just the numbers which are not rational are called irrational numbers, or in the decimal form, the numbers which is not terminating and not recurring and not terminating. These types of numbers are called irrational numbers. So for example, root 2 is an irrational number. If we try to find out the root of 2, we will have get this type of decimal, which is 1.414213 and so on. And there is no repeating pattern and there is no terminating of digits. So similarly, root 3 is also irrational numbers. Both are irrational numbers. Okay, let's move. Now inserting an irrational number between two rational numbers is quite easy. How? Just do nothing. We have to find out irrational numbers between 2 and 3. So we know the irrational numbers must be not terminating. So we have to make such decimal form which is in between 2 and 3 but not repeating and not terminating. It is quite easy. So always take this the left side number and put a decimal, then start with 0 1, then put 2 0, then again write 1, then put 3 0, then again write 1, then put 4 0, then again write 1, and repeat this process. And this number will always be greater than 2 but always less than 3, and it is, by definition, it is irrational number. So we can easily find out the irrational number between any two rational or integer. In this example, as 2 and 3 are integer numbers or rational numbers. Okay, so here the other method is given. So if we are given the 2 and 3 and the task is finding out the irrational numbers, just take root of both numbers and then multiply. So root 2 root 3 is equals to root of 2 into 3, which is equals to root of 6. So this is also can be our answer. So from both of the method you can use any of them. So the final answer would be depending on your method which you are choosing. Okay. And note, there are infinitely many irrational numbers between two rational numbers. Always remember this. Okay. Okay. Let's move to next. Now we have to find out the two irrational numbers between 2 and 2.5. It is quite easy. Let's use the second method. The numbers are given 2.25. Take root of both 2.25 and then multiply them. So root is equals to 2.25 is equals to root of 5. So 1 is this number. So we know that the 2 and 2.5, there is root 5 in between. Okay. Now again we have to find out the two numbers. We found out one number. Now again apply the same method. Same method in between 2 and root 5. So taking root of this and taking root of this, then multiplying, we get root 2 and root of root 5. Okay, so this is also our irrational number between 2 and root 5. Okay, quite simple. Yes. So the one is root 5, just simple method, taking root first and then multiplying the root values. And again, we now here root 5 is in between 2 and 5. So from 2 and here is 2 and here is 2.5. Somewhere here is root 5 and root of 2 into root 5 is in between 2 and root 5. Somewhere is here. Okay. So we applied our method again and again. Between any two numbers, we will get our irrational numbers. So in summary, we easily say that if A and B are any two numbers, then root A into root B is irrational number in between A and B. Also remember that A and B are not equal. A and B are not equal, and either A and B are non-zero, because if A is 0, then root of 0 is 0, then multiplying will get me 0. So we won't get irrational number like this. If these are the conditions, then we will try our first method I had told you. Okay. So if this method fails, these are some restrictions. There are more restrictions, I think. But if you find any other restrictions, then don't use this method. Try the first method. Okay. Okay. Now let's similarly here you can easily find out by using the methods. Let's see. So taking roots and then multiplying, it's the same. Two irrational number, taking roots and then multiplying both roots, we will get our irrational number simply. Okay. Now again taking root of 2 and the root for this, root of 2 and root for this, we will get the third or the second number in between root 2 and root 3. Okay, clear? Root 2 and root 3. So we have root 2 less than 4 of root 2, 8 of 6 less than root 6 less than root 3. So we found out two irrational numbers in between root 2 and root 3. Let's move on to now the question arises how we are going to represent or plot irrational numbers on number line. It is quite simple. First, let's plot for root 2, root 3, root 5, root 6 and so on. Let's start with root 2. First, do nothing, draw a Cartesian plane or the rectangular coordinate system. Move 1 unit on x-axis and 1 unit on x-axis and 1 unit up on positive y-axis. So we are at here. This is also 1. Now we know this is 90 degree. If we move straight and joining this line, joining here is the origin or the 0, 0 point, and this point is 1, 1, and by distance formula from between any 2 points, we have 2 points 1, 1 and 0, 0. Using distance formula, the distance formula was distance between A x1 y1 and B x2 y2. The distance is equals to root of x1 minus x2 whole square plus y1 minus y2. So here distance is equals to root of 1 minus 0 whole square plus 1 minus 0 whole square, which is square. 1 square plus 1 square, which is 1 plus 1, which is root 2. So this distance is equals to root 2. So using compass and putting one needle here and another needle here, we get the root 2 distance and marking onto this line. This will make like this if we complete using the compass, and wherever it intersect on the positive x-axis will be our root 2. Okay. Now in similar way, one can use for root 3, root 5, root 6. Let's see for root 3. Okay. So how we are going to point for root 3? So we did for, let's magnify my root 2 representation. So root 2 representation is 1 unit here, 1 unit here. This was the root 2. So using compass, the root 2 is here. So again, I draw a line of unit 1. So unit 1 such that the line and this line is 90 degree, and it is of 1 unit, and then adding again this, joining my new position to the origin position, applying again Pythagoras theorem. We know root 2 square plus 1 square is equals to length of green line. Okay, green line segment. Okay, so which is equals to 2 plus 1. Okay, length of green line segment square, or the other version is Pythagoras is equals to hypotenuse square is equals to base square plus perpendicular square. Okay, so we will get our length of green segment. The similar thing is here of root, so root 3. So the distance will be root 3. Now using compass, so using using compass, one needle is here, another needle is here, taking the same distance of root 3, we make arc, and the arc cuts x-axis at root 3 distance. In a similar way, one can plot root 5 and etc. Root 5 and root 6. Okay. And this is for homework. It is quite easy. You can see. So we plot for 1 unit here, 1 unit here, and by Pythagoras theorem or the distance formula applying, we will get root 2 distance, and then draw the 90-degree line such that it makes the 90-degree angle here. So we get the root 3 here, root 3, and then using compass, we get here. Similarly for root 4, root 5, root 6. Okay. Okay. Now, these are homework problems. So plot root 5, root 6, root 7, root 8. I have already given the root 5 and root 6, and these are some 2 more extra points too you can try out. Okay. Trying more, you will get out the concept more. Okay. Now let's talk about properties of irrational numbers. So properties of irrational numbers. And okay, rational and irrational numbers combined. So properties of rationals and irrationals. Okay, properties of rationals and irrationals. So negative of an irrational number is irrational. Take any irrational number, and negative of irrational is always irrational. For example, root 3 is irrational. Root 3 is irrational, and minus of root 3 is also irrational. Okay, so in general, irrational number. Okay, so in general, negative of irrational is irrational. Now second point says the sum and the difference of rational and irrational always an irrational. So let's see. Let R is some rational number. R is rational and I is irrational. I is irrational. Then R plus I is always irrational. Okay, clear? R plus I is always irrational. And similarly, the difference R minus I is always irrational. Okay, always irrational. But if we took 2 irrational numbers, then it can be either rational or irrational. This point is most important and most from the perspective of exams or any Olympiad or any high level mathematics test. How the third point is important? So take any two irrational number, let's say root 3 and minus root 3. These are both are irrational numbers. Yes, they are both are irrational numbers. So adding these numbers, adding these numbers, we will get root of 3 plus minus root of 3. We will get root of minus root 3 is equals to 0. And we know 0 is rational. 0 is rational number. And if we say 2 root 2 plus root 3, which is some irrational number, it is also irrational number. You will see it is irrational number. We will prove. Okay, clear? So you saw two irrational numbers, sum and the difference, either rational or irrational. Okay, always remember this point. Now the product of non-zero rational numbers, non-zero rational number with an irrational is either rational or irrational. Taking any non-zero rational number, let's say 2, and multiplying with an irrational number, say root 3. Okay, 2 and root 3, we will get our answer as 2 root 3, which is which is irrational numbers. Okay, and what if we take say irrational, let's say taking 0. Okay, taking 0 and multiplying with this, we will get 0, which is rational numbers. Okay, so if we eliminate this point, if we eliminate this main point, the product of our rational numbers with an irrational numbers is either rational or irrational. So seeing that the product of rational with the irrational is irrational here, the product of rational and irrational is rational here. So in one case we are getting irrational numbers, in the second case we are getting rational numbers. Okay, so if we eliminate the non-zero, if we eliminate the non-zero rational numbers, then we get the fourth point, which is the product of rational numbers, is either rational or irrational. Okay, clear? Now move to the fifth point. The fifth point says the product of an irrational with an irrational is not always irrational. For example, if we multiply root 3 and root 2, we will get root 6, which is irrational. Yes, it is irrational. But if we multiply root 3 into root 3, what we will get? 3, which is rational. So multiplying two irrational number with an irrational number is not always irrational. Sometimes we get rational, sometimes we get irrational numbers. Okay, it depends on what we are taking. Okay, clear? Okay, now move on. Now let's hear. So root 3 minus root 2 is irrational number. So let's prove that. So taking it as equal to r, where r is rational, I am assuming r is a rational number. Now taking square to both side, squaring both side, we get root 3 minus root 2 whole square is equals to r square. So I am applying a minus b whole square, which is a square minus 2ab plus b square, which is equals to, here in our case, implies 3 minus root 6 plus 2, which is equals to r square, which is implies 5 minus root 6 is equals to r square. If r is rational, then r into r is also rational. Okay, keep this thing in mind. So r square is also rational. But here on the left side, we have irrational numbers. But on the right side here, rational number. So this cannot possible. So the assumption was wrong. What was the assumption? Assumption was r is rational. So r was not originally rational. So taking r rational, we will get r contradiction. So root 3 minus root 2 is irrational number. Clear? I hope this is clear. So let's see the steps. The steps are the same as I did. Okay, squaring both sides, simplifying this, get this, and okay. So okay, I forgot to put 2 here because of this minus 2ab. Okay, no problem. So okay, clear? Now the left hand, the reason is the same. This is irrational, but r square is rational, hence it contradicts our assumption that is rational. So originally root 3 minus root 2 is irrational. Okay, so thank you for your attention, and I hope you learned new thing from this lecture. So thank you for attending.